Good evening to Mr. Tang. My name is Nur Atiqah Binti Sukerdi and I'm from DCC50203. So today I'm going to present the reinforced concrete design of project design. So my name is Nur Atiqah Binti Sukerdi. Again, and the matrix number is 05DK19F1127. So this is the plan, and for my part is on this CD35. For the CD35, the Ly is 3 meter and Lx is 3.8 meter. For the ratio is you have to divide Ly per Lx. So Ly is 3.0 and Lx is 3.8. So 3.0 divided by 3.8 we will get 0.79. That is smaller than 2.0. If it is smaller than 2.0, it is 2 ways left. And for this project, it was given cast 5, too short, it is continuous. For the specification, the characteristic action thickness, you have to divide Lx over 35. Then 3800 divided by 35, you will get 108.57 mm. So we use H equal to 125 mm. For the fire direction, we use RE190, and H we use 125. So for GK, we use this GK equal to 25 multiplied 0.125 plus 1.0 as the finishing, and we'll get 4.13 kilonewton per meter squared. And as the reinforced concrete, we use 25 kilonewton per meter square, and for the finishing is 1 kilonewton per meter square. For the variable action, QK already has given by Mr. Tang, it is 2.2 kilonewton per meter square. For the design action, we use the formula 1.35 GK plus 1.5 QK. It is equal to 1.35 times 4.13 plus 1.5 times 2.2. We will get 8.88 kilonewton per meter. Then, for the design life is 50 years. The fire resistance, we use RE190. The slab thickness is 125 mm, and the exposure class is XC3, moderate humidity. We get this info from the book. The concrete inside buildings with moderate or high air humidity. External concrete sheltered from rain. The bending moment, we refer to duration 0.79. We use it as 1 mm. Moment short span MXX. We use the formula for the negative MSX equal to BSX ND times LX squared. So we'll get 5.898 kilonewton per meter. For the positive MSX equal to BSX times design action times by LX squared, we'll get 4.36 kilonewton per meter. For the moment long span MSY, the negative MSY equal to BSY times design action times LX squared equal to 0, because we follow the table from 7.2. The positive MSY equal to BSY times design action times LX squared will get 4.360 kilonewton per meter. Next, this is the PMD coefficient. Next is the materials. Characteristic strength of concrete FCK equal to 30. We've used this depend on chapter 1 table 1.0 page 19. The characteristic strength of steel FYK, we use 500 kN per millimeter square. It's from the chapter 1 page 19 class 3.2. Unit weight of reinforced concrete 25 kN per meter square. We assume bar 20 mm. We divide by 2, we'll get 10 mm of the radius. The length we assume 8 mm. Is the durability, fire and bond requirements. The minimum cement content is 280 kg per meter cube. Minimum cover with regard to bond C min B we use 8 mm. Min cover with durability we use 25 mm. Min dimension and axis distance we use 15 mm. Allowance in design for deviation we use 10 mm. The nominal cover C naught equal to C min plus deviation equal to 25 plus 10 equal to 35 mm. The main reinforcement dx equal to hash minus the C nominal minus 0.5 bar. So hash is 125, the C norm is 35, and the bar that we assume is 20. So we use it on the formula, we'll get 80 mm for dx. For dy equal to hash minus C nominal minus 1.5 bar. As we all know, hash is 125, the C nominal is 35, and the assumed bar is 20. So we use it on the formula, we'll get 60 mm. For the minimum and maximum reinforcement, this minimum, we use the formula, we'll get 108 mm square per meter. So we assume the specific bar as hx 250. We assume it was 113 mm square per meter. For maximum 0.04 times 1000 times 125, we get 500 mm square per meter. Next is the short span. The positive span MSX, we use the formula to find MSX to find the K, Z as request and provide. As request, we use the formula, then we get 139 mm square per meter. As provided, we use on the table, we use the hash x 200, and we assume it was 141 mm square per meter. For the support MXX, use the formula 2K and Z, and as request, it was 174 mm square per meter, and as provide, we use on the table HX 150, we use 189 mm square per meter. Long span. The positive midspan MSY, we use the formula K and Z. As request, we count depend on the formula, we get 348 mm square per meter. And then as provide, we also use depend on the table, it was hash 675, and we use 377 mm square per meter. For the support, MSY is 0 because it was on the table, and the K and Z and the request is also 0, so there is no as provided. Table for the calculation. The maximum design shear force. We use the formula for BED is 16.87 kN per meter. For the design shear resistance is We use the formula for VPDC. We found that 2.58 is bigger than 2.0, and then the P1 is 0.002, that is smaller for SAM is 0.02. RD is 90 kilonewton, V minimum is 63 kilonewton. So VRD equal to 63 kilonewton, that is bigger than VD. Deflection, percentage of required tension reinforcement. P, we use the formula as request divided by BD, we'll get 0.0017. For the reference reinforcement ratio, we use the formula, but we'll get 0.005. Factor for structural system, K equal to 1.0. So we use the formula. We'll found the 103.92. Modification factor for span less than 7 meter equal to 1. Modification factor for steel area provided, and the formula is as provided divided by as request, and as provided is 141 and as request is 139. Just divide it and we will find 1.01 is smaller than 1.5. Allowable span or effective depth ratio. Allowable, this is the formula, 1.03.92 times 1 times 1.01 equal to 104.96. For the actual span, 3,800 divided by 80, we'll find 47.5. That is smaller than allowable, and that is okay. Cracking. The hash is 125 mm. The main bar is max slabs equal to 3 hash smaller than 250 mm, and the bar spacing is 200 mm smaller than the S max slab.